Now let's find out how a refrigerator works and what is its coefficient of performance. So what basically a refrigerator do is, for that let us consider this example. Let us consider an apple at a temperature of 12 degrees Celsius. Let us assume that its temperature is 12 degrees Celsius. And the surroundings is at a room temperature of 25 degrees Celsius. So basically this apple is at a temperature less than that of the surroundings. So let's call this apple as sink, because we consider sink as the region where the temperature is low. And let us consider the surroundings as the source. Okay. So what this refrigerator has to do is, it has to again remove the heat from the apple. Why it has to do that? Because its basic function is to cool this apple. Let Q2 be the amount of heat it has taken from the apple, so that the apple cools. But in order to operate the refrigerator, we have to supply some kind of energy, or means you have to put the plug in the refrigerator so that it will consume the electrical energy. So a work has to be done on the refrigerator in order to operate it. So W be the work done. And let Q1 be the amount of energy or the heat it transfers to the surroundings. So this is the basic working of a refrigerator. So we define a term called coefficient of performance. Coefficient of performance. We call that as COP. This basically indicate the performance of a refrigerator, coefficient of performance. Before that, let us take the law of conservation of energy. And you just look at the arrows. These two arrows get into the refrigerator, which means the energy used into the, or energy entering into the refrigerator is equal to energy rejected or ejected by the refrigerator. So W plus Q2 is equal to Q1. So W will be Q1 minus Q2. Let's call that as equation number 1. So how will you find the performance of a refrigerator? That is coefficient of performance. So how will you measure its performance? What this refrigerator basically do is, it removes the heat from the apple. So how much amount of heat it removes from the apple divided by how much work has to be done on to the refrigerator to do that. So Q2 divided by W. That's the performance of a refrigerator. So Q2 divided by work means Q1 minus Q2. So that's the coefficient of performance, expression for coefficient of performance. You can write this as COP is equal to, this is one of the formulas, and you can take this Q2 out from the denominator, that is Q2, then here it will be Q1 by Q2 minus 1. You can cancel this Q2 and Q2. So COP will be 1 divided by, heat is always proportional to temperature. The flow of heat actually depends on the temperature of the sink and temperature of the surroundings. So you can write Q1 by Q2 as T1 by T2, where T1 means the temperature of the surroundings and T2 means the temperature of the sink, temperature of the source and temperature of the sink. So here you can substitute T1 by T2 minus 1, and this will be COP, coefficient of performance, equal to 1 by T1 minus T2 whole divided by T2. You can take this T2 to the numerator. So coefficient of performance is equal to T2 divided by T1 minus T2. Clear?